All right. Let's see. Homework was the substring dude. What was the homework assignment? String to char array. Okay, thanks. Oh, we wrote substring. I guess I just needed to look in front of us. Okay, so we were supposed to write static char array, string to char array, something like that. And this guy would take in a string s as a parameter. That dude. All right. So, in order to create an array, and we've seen the syntax. So, if you kind of notice the path we're going down, we keep introducing syntaxes for different things, and then the homework assignments are to bring 2 or 3 things together that we've learned. So it's it should be a slow torture. So as you're working on the assignments, I expect that. I don't know. I would expect these homework assignments to take some of you as little as maybe 20 minutes, but a majority of the class probably a couple of hours, something like that. Is that roughly what these are taking, ish? All right, so that's good because as you're going through there should be syntax errors that you're trying to chase down. You forgot a semicolon. You're kind of learning what the error message Java is giving you is, and all those types of things, and that's all part of those reps you have to put in to become a programmer. And at some point you will have made all the mistakes and seen all of the error messages that when you see a certain error message pop up, you'll be like, oh, I need to go and do this. It'll be fairly obvious. So there is a method to the madness, I suppose. All right, so string to char array. First of all, just as a quick reminder up here, to create an array, we've created integer arrays, we've created char arrays. You would say the type, open square bracket, the name of the array equals new char array 10, something like that. And this will create a array stored inside of a variable named AR. Well, it actually creates a memory address stored inside of a variable named AR. How do we know it's a memory address? Because the new keyword's involved. That guy's our real estate agent and goes out and gets us a place in memory big enough to hold this many of these dudes. Okay? Oh, see, I changed it up. I said these dudes, not these guys. Yep. Yeah, pretty chill. I've been trying to use chill at home, and my wife doesn't get it. Actually, she made fun of me. She says she's heard of that before. And usually I'm the cooler one out of us. So that bothered me.
You learn any other words?
Yeah. I mean, that's your contribution to this learning experience.
All right.
Yeah, I'm teaching you the programming stuff. You have to teach me how to function in modern society with young people. I mean, otherwise I'm going to be stuck dealing with old folks like Dr. Locklear. We don't want that. I mean, they're just so sickly. I think he jogs all the time. He's like the epitome of health. Yeah, he's going to outlive me easily. Well, I mean, look at you. I'm a distant sprinter myself.
Yeah.
No.
What distance?
not even that. There's no sprinting involved ever. Although recently I did dive onto the front of a boat from a pretty far distance. There was an incident because there's where I put my boat in the Milwaukee River right now, that they haven't put the dock out yet because officially fishing season hasn't started into the other places. But I decided it was a little bit warmer a day last week, so I decided to put in there. So I back it down the ramp, and then I tie off at like a post somewhere. And usually it's not a problem. And I decided to go lazy route this time. Instead of backing in and just pushing it off and then kind of pulling the boat back up near the shore, I figured, oh, well, I'll just go ahead and just, you basically back up real fast and slam on the brakes. And the boat slides off the thing. Well, the current was up. so the boat kind of went down a little bit. The line I have is probably, I don't know, 40 feet. It's probably 2 20-foot lines attached to each other. So it went down, 30 feet a little bit, and then wrapped around this tree and kind of got stuck there because I have a seat in the back that you can sit up on for fishing, but I usually stand. But in any case, I couldn't pull the boat to get back around so I basically do this dive into the tree I probably had to cross, I don't know, I would say at least a 4-foot span of water, which doesn't sound huge, but at 370 pounds, that's defying gravity. All right, I mean, you have to have, and it's a jump up, so I had to go Air Jordan style, and I had to dive through branches. So I'm like grabbing onto these branches. So I ended up doing it and kind of swung myself around backwards and landed on my back on the boat. But then I had to, peel myself out of the tree. But yeah, so that was my exercise for the year. I did on the golf cart. I did. Besides, I usually pull up right next to the ball and then get out to hit my shot. But I did walk probably 30 yards to the bev cart. We were selling beer, so it was a motivation. It was Guatemalan beer, actually. Do Guatemalans have beer? Oh, see, I just made that up. Now I just learned. Is it?
It's the translation would be rooster.
Rooster?
Yeah.
What's the drinking age in Guatemala? Oh, so like when you guys go down and build houses, that's what they have like in the Gatorade cooler? That's my type of house building. And at my age and my size, I've become a supervisor. And then about a gallon and a half in, I become a fun supervisor. All right, so string to char array. This is the size of our array, the number of chars we want to store. So in our case here, we want to store the same number of chars that live in the string. And how many characters live in string S here? S dot length number of characters. So we'll go ahead and create a char array AR, and this guy's going to be equal to a new char array of size S dot length. All right, so now we've built our landing area, okay, a la the front of my boat. So we built the landing area for the characters that belong in our string. So now what we need to do is the string's length, AR.length, without the parentheses on it, is the same as S's length. So these guys are effectively parallel to each other, right? If one guy has 5 buckets, the other one has 5 buckets. So it doesn't matter how we write our loop, whether we're going to spin through every element of AR or we're going to spin through every element of S, because in either of those cases, all we're doing is taking our variable I on a journey between 0 and the length minus 1. Right? How we use that integer is up to us. So we'll go ahead and we'll write the loop both ways just so you can see the difference. So we'll say for int I is equal to 0, I is less than S dot, S dot length, I plus plus, and then we'll say AR at bucket I is equal to S dot char at I. Okay? And then ultimately we will return AR, like that. All right, so this is if we're going to have this loop operating on the length of S.length, or the length of S. If I wanted to operate on the length of my array that I previously built, which should be the same as S.length, I would say AR.length, like that. And notice that length here has no parentheses on it, right? So based on what we learned last class, and what we've learned up to this point, but this was something we specifically talked about last class, what kind of animal is length here? Okay, if we assume arrays are stored as objects in Java, which they are, which is different than C and C++. Java has pulled the primitive type arrays into an object type in Java. So if we look at this and we assume AR is an instance of some class, the array class, let's say, what is length? What kind of animal is that? We have 3 options. Okay, so last time we talked about the different types of members that could live in a class. What are those 3 options? Okay, so fields, constructors, methods. That would have been a good quiz, right? Yeah, is that? You ready for it? All right. Well, maybe next time. Maybe remind me. It's like maybe is this a quiz day? And then I'll come up with a question. But I mean, if you want to be bold, you can say, "Is this a quiz day?" I suggest you. Hey, I'm a pretty good sport. I might take. Go ahead. Quiz day. And you're only excused for a first place. And you're playing against a powerhouse, right? Augustana? They sound scary.
It's the meat of champions.
The meat of, aren't they a religious school too?
I think so.
I'm pretty sure. I think I want to say Augustana is maybe Nazarene, or yeah, I'm pretty positive they're a religious school. So typically, when I hear religious school, I think not good at sports. I'm not saying anything.
Notre Dame.
I'm mediocre at sports sometimes. Historically good at sports. Yeah. Well, same thing, BYU. Yeah, but I mean, it's Mormonism. Is that really a religion? I think at Concordia I'm allowed to say that. Because we're supposed to teach a Christian, a specific Christian worldview. We don't think we recognize that. But whatever. All right, so this would be, okay, so you mentioned that the three different animals that live inside of classes are fields, constructors, and methods. Which guy is this? It's a field. How do you know? Okay, well, just looking at this, so let's kind of practice identifying. If I just highlight this, how do you know that guy is not a method? You could also cut out constructors as well. What part of what I have highlighted there immediately tells us it's not a method and it's not a constructor? What do all methods have? Parameter list. Every single method is going to have an open and closing parentheses. They might not take any inputs, and they might not take parameters, but they all will have parameter lists. All right, so the fact that we do not see that there, or that plus something in there, immediately tells us it can't be a method, and constructors I advertise as being kind of like special purpose methods. All right, they also will always have parameter lists. They may not take a parameter, but they'll always have it. So the fact that we see nothing there immediately disqualifies all the other guys and says this must be a field or an error. one of the two. All right, and since Eclipse is an underlining stuff here, it's not an error. Okay, so this says, give me the value contained in this variable length, which belongs to this instance of the array class. And that variable, which is going to be an integer type, will ultimately boil down to the number of characters that array is capable of holding. Okay? Because understand right here, when I build this array is capable of holding s.length number of characters. But how many characters are currently in the array? There's 0. All right? We've built a bucket or a container with a bunch of little slots like a shoe bench thing for holding some number of characters, but we haven't actually put any characters in there. With a string, if we say s.length, that's returning the actual number of characters that live in the string. All right, and part of the reason for that is strings are read only. We cannot change the contents of a string. If we want a string to change its colors, what do? We build a new string. Right? If we need to modify a string, we build a brand new one. Right? So we'll actually be doing that here in a few minutes. Okay, so this is going to say start I off at 0, keep going as long as I is less than whatever the length field of AR boils down to, which is the exact same number as s.length, which is a method, right? S.length, like this, we know that this guy is a method. Well, we know it's a method or a constructor. Okay, one of those two. We're going to identify this guy as a method because well, first of all, constructors are only called when the new keyword's around, and we'll cover that when we start writing those ourselves. And they also always match the name of the class. So since this guy doesn't say string, not a constructor, this guy's a method. But for right now, we should be able to very, very, very clearly tell the difference between fields and constructor method thingies. All right? By looking for open close parentheses. That's it. All right, we should be quick at that, just like we should be really good at detecting instance things from class things with the static keyword. So when we're looking at the definition of a field or the definition of a method, if static is in front, it's owned by the class. If static is not in front, it's owned by an instance of the class. Okay? So we're just looking for little, pieces of geography, if you will, in the syntax that tell us pretty quickly what kind of animal we're dealing with here. All right, so AR.length field is identical to S.length method in terms of the value it will ultimately boil down to here because we built our array in terms of our string. Make sense? All right, so pick your poison however you want to go through this guy. So we'll go through every element of we'll go through every element of our string. Each time we'll take the current character we're looking at and we'll store it in the corresponding position, corresponding bucket of our array. Ultimately, we'll return this array. Okay? So now, if I, heads up, I'm about to trick you. So we'll say string, and this is based on something we looked at last time. Not something we really harped on, but we did talk about it for a second. And we'll go ahead and say char array AR is equal to driver dot string to char array. We'll pass it S. And we'll go ahead and print out AR. And just as a quick example here, int array AR2 is equal to a new int array 5, let's say, and we'll do a system.out.println AR2. So here I'm defining an integer array, and I'll print out that integer array. What do we expect to print out here? What will the output of that system.out.println be? It'll be something. You're right, the array isn't filled with stuff yet. So we've built something capable of holding 5 integers. So we went out to Home Depot, we bought does Home Depot sell shoe benches? Who sells shoe benches? Colders. Colders probably sells shoe benches. Go and buy a shoe bench from someplace. And even though, so now we have a shoe bench, but there's no shoes in it. This is a shoe bench capable of holding 5 shoes. Even though it doesn't have any shoes in it, it exists. It's a thing. So you said initially nothing will print out here. Then what did you say? Empty line. Okay. No. We've seen this print before. So this is a reminder. I also referenced it a few minutes ago. Memory address. Why is it a memory address? You're right. That's what it will be. Is there any piece of geography you might see in this line that indicates it should probably be a memory address? Yeah, the new keyword. Remember, this is our real estate agent, goes and finds some memory for us. So ultimately what AR2 is a variable which holds a memory address that actually points at our shoe bench. All right, points to the actual array that was created. Okay, so when we print out an integer array, it prints out a memory address. So now we're going to create a string s is equal to hello. And remember, I'm trying to trick you. And now we have a char array. And that guy is going to be whatever gets returned by string to char array. We pass our string to this guy. Notice we're using the new keyword in here to build our array. So even though we didn't use it directly out here, we're indirectly using it. So we're still getting memory. We go through, we fill up that array, we return the array as a char array, storing the result in AR. So when I print AR, what should print out? What would be the, based on what we've talked about in the last, 60 seconds, our gut feeling would be this would likely print out a memory address, right? Okay, because the new keyword's involved, and just like up here with our, I haven't run it yet, but trust me, this will be a memory address. So since this is an array, and it uses the new keyword, we print it out, we get a memory address. Since this guy's an array that gets filled up with the value of this array, which was built with a new keyword, logic would follow that this guy will likely print out a memory address, right? Okay, but he won't actually print out a memory address. What will he print out? It'll print out hello. So let's run that and see it, and then I'll ask you why. All right, so here's the memory address of our integer array. That's our system.out.println of our integer array. This is our system.out.println of our character array. Why is a character array, why does it show hello like this instead of a memory address to a character array? This was based on something we talked about last class. Specifically when we were looking at the Java documentation. We introduced a new word last class. Crazy sounding word that means something easy. Remember what the word was? The definition was more than one method with the same name but a different number and or type of parameter. Polymorphism. Also a quiz, possible quiz. Okay. Okay. Hey, those will come back. You got to keep reminding me if you want to bolster quiz grades. Man, I would love for classes to request quizzes. that's not going to cut it. I know your name too. You're the guy I put the low scores next to. Boom. Oh, and also the guy with crappy weighted throw record. Yeah, that's right. Division 3. That's right. Although I think we've had a couple of football players from here end up going into the NFL. Isn't that a true statement? Any football players? Yeah. I mean, I don't know if they became superstars or something, but point is it doesn't make it impossible for that path to exist. Obviously, you probably have a better chance playing for like Florida State or teams that well, I guess more recently like Nebraska and Ohio State. Certainly, half the team goes to the NFL. Alabama is basically an NFL team. So, it would be interesting to see a game each year with the worst team in the NFL versus Alabama.
Alabama versus the Jaguars?
Yeah, I mean, the worst team in the NFL would beat Alabama. But it would probably be closer than it should be. The NFL players, you can't deal with the size of them, and these are all studs in college, right? So even though they were crap teams, they had junky team chemistry, doesn't mean that these guys aren't going to break college students. But if anybody's going to stand up to it would probably be Alabama. I think their average weight of their defensive linemen is like 40 pounds heavier than like the next team. But I think their 40-yard times are 30% quicker than the next team. So fast guys. That's very dangerous. That's a weighted throw. That's what it is. All right. So this guy printed out the actual string. So we talked about polymorphism. Polymorphism is the same method with multiple methods with the same name but a different number and or type of parameters. What did we see last time when we were exploring the string class, or I'm sorry, not the string class, when we were just exploring the print stream class, when we were following the yellow brick road for system.out.println? What did we find about print and println? That was an example of polymorphism, right? There was a whole bunch of those guys, and let me just bring it up here since we're so we had a whole bunch of versions of print and we had a whole bunch of versions of println, and what we're going to find is there's a version of print and println that knows how to print a string. There's one that knows how to print an object, and so the object is like the catch-all. Okay, if you're not an int, you're not a byte, you're not a short, you're not a string, you're an object. So the object, what it does is it calls the generic objects toString method. All right, that every object is guaranteed to have. But there is a version that also takes in a char array. So here's our system. Here's our out field, which is a print stream. And then here's our printlns. Well, print and printlns. Let's just go. So here's our guy that knows how to print out specifically a char array. We don't have the equivalent to that for integer arrays or any of the other arrays. So those guys fall into this version of println. Okay, and that version of println prints out the toString method of that object. If we go to object, all objects, so this is the most generic thing you can have in Java that is an object. So this is literally like us just saying human. Okay, not male, not female, not Mike. We have no form to it, but technically it's an object. Okay, and all objects have a toString method that makes it compatible with the println, system.println, and print. So when we pass it an object, when it doesn't know anything else to do with it, it calls that object's toString method. And every object is guaranteed to get a toString method. It will either have the one that it inherited from its parent, its great-grandparent, whatever it is, or they could define a more local copy of it that does something maybe more appropriate. Maybe you have a patient record and you decide to write your own toString that returns a patient record information instead of crazy looking memory address. Okay, and we'll explore that when we get down to that stuff. But for right now, that's our trick. So when we say system.out.println and we pass it AR, which is a char array, there is a version of println that specifically knows how to handle char arrays. There is not a version of println that specifically knows how to handle integer arrays. That dude gets bumped to the version of println that knows how to handle objects. Make sense? Okay, so this all has to do with how the documentation is working and stuff like that. Now, having said that, could we write our own method for displaying the contents of an array? Okay, contents of an integer array? Yeah, we could write our own display on that. Maybe we just spin through every element of the array and do a print. Maybe we build up a string of the contents of it and then print it out for all the numbers that are in there, something like that. So we could certainly build our own if we decided that the default println wasn't adequate for us with the memory address. Now, having said that, do you think it would be very common for us from a problem-solving perspective for us to actually have to display an array? We might display an array just from a debugging perspective, just to make sure the stuff we think is in the array actually is in the array. You know, that might be something we're interested in. But having said that, typically if we're creating an integer array, we're creating it to store a bunch of integers. And we're probably going to be using those integers for some other aspect of our application. That make sense? Okay, so this is string to char array. What if we wanted to do char array to string? Go the other direction. So that is, we'll take in something, what's going to return a string. Call this guy char array to string. It's going to take in a char array as a parameter. Okay, now we're not going to create a new string from that's the same length as our char array. That's not how strings work. We're going to have to build up our string starting with the empty string and concatenate onto it each char that we run across. All right. So we'll have our string answer is equal to the empty string. That's the string we're going to be building up, in which we're going to be building up. And you don't have to call it answer. This goes back to us talking about making your variable names meaningful names. So this is the answer we're going to be returning, so we decided to call it answer. Then we're going to have our loop. Our stock loop for going through an array. Any kind of array is very similar to our stock loop for going through any string. So for int I is equal to 0, I is less than ar dot length, except that is the length field, I plus plus. Each time through, we're going to say answer plus equals ar at bucket I. So this is how we get a value from an individual bucket of an array. That's kind of equivalent to s.charat. Okay, so Name of the array, open square bracket, index, close square bracket, boils down to, if it's on the right-hand side of the equivalence operator, this guy boils down to the value that lives there. If it's on the left-hand side of the equivalence operator, so for instance, if I say that, when this guy's on the left-hand side of the equivalence operator, he becomes the, effectively a variable. This is the bucket that's going to catch the value that we are assigning. Okay? This is an example of why arrays are read-write. We can set a value at a particular bucket. We can also get a value at a particular bucket. With strings, we can only get a value from a particular bucket with char at. If we need to set a value at a particular bucket, we need to build a new string. Okay? There's actually a class built into Java that some of you have actually used, and I'm not officially teaching it now anyways, but called string buffer that effectively lets you set an element of a string. But I promise you under the hood, it's building a brand new string. So it's just doing what we're doing anyways. It just happens to give us a nice wrapper for it that's already been built. So, in case that's something that we might, that might be something that we commonly do, is change the value at a particular element in a string. Okay. So we'll go ahead and concatenate on the contents of that char array. Then we're going to come down here and we'll ultimately return answer. All right. So now, so we got to spell answer, right? That was the Guatemalan. It's pidgin English. Is that a thing? Do they speak pidgin English down there? Something. That's just broken English. Pidgin English is actually a language. Pretty sure. It's legitimately a language. So you just learned something. I think some of the islands I've been to on cruises, they speak pidgin English. It's like shorthand English. That could be a quiz. Maybe it's Bermuda. I think Bermuda might have a national language that's pidgin English. Why waste your time with all the filler? It's kind of the thing. All right, so char array, we should be able to pass this guy a char array, and it should be able to spit back out the string equivalent. So here's us printing out that char array. Now let's go ahead and say string convert back is equal to driver dot char array to string. We happen to have a char array named AR that we can send that guy. And then we can go ahead and say system.out.println convert back. And we should see that this gives us our hello. So hello went from being a string to a char array, then back to a string. How can we prove that? I'll show you a new operator here. So we can say if, actually I'll just print out this for the operator since we don't have a real good use for it right now. So we're going to say convert back instance of string. So the instance of operator boils down to true. This is a Boolean operator. The instance of operator boils down to true if the guy on the left-hand side is indeed an instance of the guy on the right-hand side. I guess this might be a dude, the dude on the right-hand side. Does that sound right? That is the dude. Do you approve? All right, perfect.
Have you seen the movie The Big Lebowski?
Yeah, I'm the dude. All right, so this will boil down to true if it's one of those and false otherwise, so we should see a true there for that convert back. If we put AR in there, see, I mentioned earlier that AR strings are object types in Java, but they're hidden object types. The older language C and C++, arrays are actually primitive types. Java turns them into an object-like type, but it's still technically treated as a primitive. That's why it's screaming about this. incompatible conditional operand, char array, and string. So it's basically saying this guy can't be compared with the instance of operator. Trust me, it's still an object under the hood because we've seen it use fields. In older languages like C and C++, arrays were not able to tell us their length. If we needed to have an array with 10 elements in it, we would have, and we were passing that to a function, we would have to pass the array as well as an integer telling us how many things are in there. Make some sense? Evidence is actually in our generic hello world program in C. So let's go back here, and I'll do let's see, ls*.c. We got, let's do vi test.c. All right, perfect. So here's our hello world in C. Compared to, let me just real quick, I'll just write the equivalent line in Java up above here. I'll just write it. So this guy is public static void main string array args in Java. So this line and this line do the same thing. Okay, this is the main method. All programs begin and end with main. This is the main method in Java and C, respectively, for taking command line arguments. So we can pass something in the command line. A char pointer argv, this guy, is a string array. That's what that is. This is a char pointer that points to the beginning of a string, and then this is an array pointer that points that says I'm storing a bunch of strings. Right, so without getting too far into pointers here, that's what that guy is. All right, so this guy takes in a string array, this guy takes in a string array. The difference is in Java, we only take in a string array. In C, we also take in the argument count. How many strings are in our string array? Because C isn't, the arrays in C and C++, they don't know how to do that. They don't know how to report their own length. Make sense? So we're seeing an evolution of how arrays are implemented under the hood. In order for Java to pull this off, they have to make arrays at the very least object-like. Okay, but they've still kind of put a shield around them and said, treat them like primitives most of the time, but we had to implement them as objects so they can do some cool stuff. Make some sense? All right. So that's our instance of operator that allows us to check whether a particular object is an instance of another object. We don't have a great use for that right now, so go ahead and throw that in your kind of a trivia bank somewhere. I won't quiz you on that until we actually have legitimate uses for that type of thing, but at least you've seen that operator, so if you're looking at code online or something, you know what it's kind of doing. All right? So let's see, char array to string, string to char array. Let's see, we have not done sorting yet, right? Okay, good. So let's go ahead and we're going to say static let's start off with having a print array. So we're going to do print int array because we're going to mess with integers for a while. And this guy is going to take in an integer array as a parameter, and he's going to go through and print out the contents of that array all on one line. We'll just put a space between each character. That'll make it easy for us to visualize the contents of an array. So we'll go ahead and say for int I is equal to 0, I is less than ar.length. That is the number of elements in the array that was sent to us, regardless of what kind of array it was. I++, and we'll do a system.out.print AR at bucket I. And then in the end, we'll do a system.out.print. I like to use the one that I just passed the empty string. There actually is a print that takes no parameters that literally just kicks it down the line. So pick your poison. All right, so that guy will print out every element of our string array. Oh, we probably need to put a space after that guy. Okay, so followed by a space to kind of separate them a little bit so we can visualize it. And we're going to go ahead and we're going to have a static void fill array with random ints, to spell it out, I guess. And this guy will take in an int array AR. And we want to go ahead and fill up that array with some random integers, random data. And we'll fill it up with numbers between 0 and 100, let's say. So have we looked at the random class yet in here? All right, so I'm not really going to deal with the random class too much for this exact moment, but we're going to use it to fill this guy up. So we're kind of introducing a new object called random that allows us to get random data. Random ints, random doubles, random booleans, so random of all of our primitive types. So we're going to say random r is equal to new random. So one thing we're seeing here is when we create something, an instance of an object, we always use the keyword. This is the constructor for the random class. Notice the constructor has the exact same name as the class name. So now this allows us to recognize constructors. All right, and random actually lives inside of java.util. And random has a bunch of methods in it. The method we're interested in is one called nextInt. There's two versions of that. So if I type in r.nextInt, notice there's one that takes in a bound, and there's another one that takes in nothing. The one that takes in nothing will return for us an integer in the range of all integers. What is the smallest integer in Java, and what's the largest integer in Java? In Java, their integers are 32-bit signed numbers, right? What's the smallest 32-bit signed number? Ballparky. Remember the slide? It's -2 billion. It's like -2.1 billion to +2.1 billion. That is plus or minus 2 to the 31st power. All right, so if I do 2 to the 31st, it's that number, 2.1 billion. All right, so for some quiz, I expect you to have memorized this to every digit. I would never ask that. Okay. But you should have a ballparky idea of what the range of integers are, in case that becomes important. Okay, so we know if we call the generic nextInt, it's going to give us some number between -2.1 billion and +2.1 billion. Some number in there. Okay, but we're going to be a little bit more targeted. We're going to use the bound version of this, and this is going to relate to something we talked about last class. So when I call this guy and I say to number 101, this is related to what we talked about with substring. Substring, that second parameter, if we say begin to end, the end is non-inclusive. So when I say 101, this guy will boil down to a number between 0 and 100. It will not include the 101. Make sense? So I want to go ahead and I'm going to generate a bunch of random integers and fill our array. So we'll say for int I is equal to 0, I is less than ar.length, I plus plus, and we'll go ahead and say ar at bucket I is equal to some number between 0 and 100. All right, we already have our print array here. So let's get rid of this. So we're going to go ahead and we're going to say int array, let's call it array of numbers, is equal to a new int array, we'll say 10. This is an int array. And then we go ahead and say driver.fill array with random ints, and we pass it our array of numbers. And then we say driver.print array, and we pass it our array of numbers. Notice that fill array does not return a value. Instead, it took in an integer array, it filled it up, but we're going to see that it actually is full out here. Pass by address. We talked about pass by value versus pass by address. We're passing it a pointer. We're passing that function a pointer of that array. So when it makes changes to it, it's making changes actually up in memory. Okay? And so now when I call print array and I pass it the same integer array, it's also looking at that same place in memory, even though these guys never returned a value. So we should see now something filled with 10 random numbers. Make sense? All right. So your homework assignment, okay, and this is more of a MacGyver type of assignment. We're going to talk about a specific algorithm for this next time. We're going to call this static void sort array. This guy's got to take an integer array AR as a parameter, and this guy needs to put the elements of the array in order somehow. All right, so derive your own algorithm for taking in this case, 10 numbers and putting them in order. If I gave you 10 note cards in real life and I told you to put these guys in order, you would be able to do it. So I want this as a practice in algorithm design. I want you to think about what steps do I take if I have 10 note cards in front of me that I would do to put those guys in order and then manipulate our array here. So with that in mind, I should be able to say driver.sortArray, passing it array of numbers, and then I should be able to say driver.printArray, passing an array of numbers, and you should see it now in order. That makes sense? So if your homework, this guy right here, does what it's supposed to do, you should see the stuff in the correct order. Make sense? All right. Draw pictures, write your algorithm first. Don't just dive into code. All right. I will see everybody on Friday. I still got to do the homework, though.
I did it last week.
Oh, you call that homework, what you did?